It's alive!
Now that's classic.
Here we have an electronic Pounce machine. And this is a kind of machine that was a staple in any sort of old sign shop. And, how does it work? Well, it takes 120 volts and turns it into high voltage. Then, when you put it on a paper pattern and your metal backer, it burns small holes on your design. So, if you're a sign painter, this is super handy because you would draw out your design on paper, trace it with this machine, which would burn all the small holes. Then you could take that design and, say, put it on a wall, piece of glass, or whatever substrate, and you pounce chalk, and now you have your design transferred onto your substrate. So these machines have been around for decades. The first ones came out in the 50s, and they officially hit the market and on the shelves in which you could buy them in the 60s. But as vinyl cutters and cheap digital design work infiltrated the market, tools like this slowly disappeared. Recently, though, there's been quite a bit of a comeback. Traditional sign painting has become a niche craft again, right? So these are becoming quite sought after, and they're kind of hard to come by now, and they're definitely hunted down by collectors and shop owners alike. 5 or 10 years ago, if you would have looked on eBay, you probably could have found one for about $200 or $300. That's definitely not the case anymore. And when I tried to find one myself recently, I discovered that it was about $1,000. And then I waited for another month, another one showed up, and it was $800. So they're definitely not cheap, and you have to be willing to sit and wait and check eBay quite often. And you may be waiting for a few months, if not longer. You can still buy these brand new. There's one company that makes them, but they are asking $1,600, which is pretty expensive. So instead, I figured I'd make my own. I thought it'd be fun to build something vintage looking, something that looks old, period correct, something that looks like an antique. It gave me an excuse to learn about the insides and outs of how to build one of these machines, and really amounted to saving money. I saved a considerable amount of money building my own. And really it amounts to kind of a badge of honor. I think it's really cool to be able to say, hey, I built my own Pounce machine. And I think you could too. So hopefully with this video, you'll get confidence to build your own. I'm going to go through a parts list. And while I will not be giving you guys my exact wiring diagram for liability issues and reasons, I think if you somewhat know what you're doing, you could probably connect the dots and figure out how to make one yourself. Or better yet, if you are lost, you can find an electrician and have them help you build this. Let's go over components. We're going to start from the wall, from the power source, and go all the way through the machine. I think that makes logical sense on how to lay these out. So first, we'll start with the momentary foot switch. Basically, this allows me to turn the machine on with my foot and turn it off with my foot. Now, if you don't have one of these and you take your wand and the machine is on and you go close to the paper, it's going to create a pretty large arc that's going to hit the paper and burn a much larger hole, right? Or you can include one of these, and so you can turn the machine off, put your wand directly on the paper, turn the machine on, and then start. And it's a much smoother process. That way your holes, you're not burning large holes in the beginning. It's a consistent size hole through your entire Pounce pattern. So we have the momentary foot switch. Next, we have the Mauser 18-AUG power cord. Basically, it takes the power from the wall to the machine. Next, we have the Mauser power entry module. Basically, this takes from the power from the wall into the machine. And it basically creates a nice, safe entry point. That way there's no tension on a cord. It's safely placed in and grounded. Next, we have the Busman 3 amp fuse protector plus 3 amp fuses. So basically, if we have a power spike or the wiring's wrong or something internally happens that is bad, this protects the machine and cuts off power. We got the Gardner Bender toggle switch. Basically, this is just our main on-off switch for the machine. This is our first vintage piece. It's a Westinghouse 120 volt panel indicator light. And basically this just tells us when the machine is on. It lights up. And inside of that Westinghouse panel indicator light, I have a 120 volt mini bayonet LED light. And I picked warm white. I think it'll give it a nice glow compared to picking a different color. Something that would be period correct in terms of this glow. This piece is the Superior Electric Company Power Stat, and it's a variable transformer, right? So basically this allows us to turn up or down our power. So the least amount of power gives us smaller holes. More power gives us larger holes. Or also, in the case of paper density, you can burn through larger, thicker paper by increasing the power. Then we have a Simpson's electric AC voltmeter. This shows us how much power we're sending into the machine. Now for the main heart of the system, we have this Acetown 4000 volt neon transformer. And what this thing does is it takes normal power and turns it into high voltage. Specifically up to 4000 volts, which is what we will need to burn thicker holes. This is a Sprague high voltage doorknob capacitor with a corona ball. This stores high voltage briefly and then smooths it out, basically creating a better output, smoother and less noisy. We have the McLogan Supply Electro Pounce cord, and basically what this does is it takes the high voltage output and sends it through this cable into the Pounce pattern. So basically this is your wand. You have a needle tip, and this is what touches the paper and the metal backer and creates that electrical arc to make the small holes. All right, we have our 16 AUG stranded wire, and basically this just connects all of our internal regular power parts together. And I have different colors so we can notate what's what when we wire it all together. All right, then we have our 18 AUG copper core silicone wire, and this is rated up to 30,000 volts. So this is the wire that safely carries all the high voltage power in our machine. So from the neon transformer, this is what we connect to that, so we can safely carry a higher voltage. Then we have the 14 AUG stranded grounding wire. This is what grounds all the components together. This is also what will be running out to the metal backer from the machines, and I'll probably screw it in or use an alligator clip. Then we have the square terminal grounding bar. This is basically where all the grounds are going to connect to one central point. So we needed an enclosure for all these components. Now I wanted something vintage and period correct, and so I found this SureShock electric fence controller. Super cool little metal box. There's some components in it, so we'll have to remove them, but everything should fit in theory. It might be a little tricky, but I think it'll work. But regardless, this is a really cool box. I have no idea when this was made, but it's definitely vintage and it looks really cool. I think we'll do some hand lettering around this, and I think we'll complete the project and look really cool. So that's it. These are all the main components that will fit inside this box, and this is what's going to make our Pounce machine work. Just make some small modifications here and there. Cut some holes in the box. Depending on how hot this gets, we may have to add some different metal louvers to this to allow air in and some cooling. But that's about it. This is going to be a really fun project. It's really cool to have custom. I mean, yeah, you can buy something off the shelf, but the idea of making it yourself is pretty cool. And homemade things, hand-built things, custom-made things are infinitely cooler than store-bought things. Just my opinion. I guess we'll start. So this box was originally an electric fence controller. So basically, it shocks the animals when they touch the fence, but it is more of like a warning signal than death, right? So it seems kind of a shame to gut this thing, but I have no idea if it works or not. And at the end of the day, I don't have a large fence or animals I need to keep in it. And having it relive a new life as a Pounce machine is just as cool. So I'm gonna take the bump screws off. So this thing is constantly going back and forth, and when it makes a connection is when the voltage carries through to the fence. Pretty fascinating. Couple noted changes from yesterday is I did go ahead and get a different voltmeter, which is smaller, and this was the original vintage voltmeter, but I had some serious concerns about everything fitting and then also just layout preference. So I did switch to this modern version of voltmeter. Still reads up to 150 volts, and it's obviously much smaller, and I think it will complement the power stat. So here's the dial of the power stat, and then this will be the voltmeter. And I think this combination looks a bit better. Obviously I wanted to do something vintage, but this one will have to do. We're just trying to get the bit from traveling. I don't want a bunch of chatter and then it, skates along before it finally bites in and starts cutting the hole. So we're going to try to clamp a piece of wood, and hopefully that will keep the tip of this bit, centered, and that way this exterior hole saw doesn't travel as much. So that's the goal. Off and have some perfect holes. All right, got the power stat assembled. All right, on-off switch. Yeah, there's a couple burrs, metal burrs that we need to fix to be able to get that to fit in. There we go. All right, guys, it is a new day, and I had new parts show up in the mail. We have this 8x6 louver panel, which I think is period correct, so I think it would look good. The problem with this box design is it only lifts up and then you can see the components, right? So in order for that to work, I would have to have extra long wires, right? So when this part comes off, it's still wired to the base, and then you put it together. But then you have long wires that you would have to try to kind of stuff in the base and hope that nothing gets pinched or there's any problems with your wires touching other wires or whatever, right? So not really the best best way to manage the wiring. So I decided to get a vent cover, a louvered vent, because it's period correct, but also because then I could cut a hole on the back side of my box and mount the louvered panel, and then it, has two functions. A, I can remove the louver. Now I have access to all my wiring. But also B, I was a bit worried about the heat retention in this box of all electrical components, and, excess heat may lead to some problems. So with this added louver, we now have ventilation into the box, airflow in and out, so we can keep this box much cooler. So it'll be like that, and then you remove it. Now we have all this space to get our hands in and wire things. And I think that's plenty. It's still going to be a little tight, don't get me wrong. Got our markings for this piece, power entry module. So again, we'll just make a couple of holes. Then we'll use our step over bit to get up to 1/2 inch. That way we can get our jigsaw blade in there. So I want a vintage look in the letters, so basically what I did is just really cut down the alpha enamel with mineral spirits. That way it's basically a wash instead of, full-on paint. And then I was able to take a red Scotch-Brite pad and just kind of go in and rough it up and sand it down a bit to kind of blend in a bit better. I designed myself a nice, fancy wiring schematic. Again, I don't want to show you guys because I really don't want anyone to get hurt. I think what I'm showing you guys is enough to get you started, and you could probably figure it out from there. Or, you take the components and find yourself an electrician friend or whatnot and have them help you. And I thought it'd be kind of nice to actually have a printout of the schematic. That way I could fold it up and store it in this box as well. I like the idea of, one day this thing gets passed on to someone else, and it's 60 years from now, and they open up the box and they find this cool little wiring schematic. Anyways, kind of cool. So here's my machine. It's called the Pounce-O-Matic is what I called it. Then I said Shirley to Shock is a fun little play on the vintage metal case I found, which is called Sure Shock. I really like the vintage look. I like the vintage sticker on here of this branding, so I kind of want to play off that And so that's why I did Shirley to shock. You got your voltmeter, your on-off switch, variable auto transformer here. We have our indicator light up above, our fuse here. We have our power entry module on this side. Over here, we have our wand and our wire that connects to the backer panel. A little handy hook to hang all the wires. And then on the back side, we have a louvered access point that also acts as ventilation to the system to help keep it cool, but also a access point where we can access all the wiring. Everything's wired up. So, moment of truth, I'm going to turn it on. And hopefully there's no problems. Again, I bought some of these parts off of eBay, so they say they're good, but you never really know. So fingers crossed, everything is good. All right, guys, let's power this thing on for the first time. As you can see, nothing happens when I turn this on, and that's because I have to make sure I put my foot on this momentary switch. Once I put my foot on the switch, when I turn it on, that's when our indicator light actually turns on. Woo! So we got power. It's on. And again, here's our voltage. And we can change the voltage based on our needs. Less voltage means smaller holes. More voltage means larger holes. And so we're going to take our wand and we're going to put it on our paper and our metal backer. Now the machine is technically on, however, I don't have my foot on that momentary switch. The momentary switch enables me to basically safely start and stop so I can, touch the panel and nothing happens. As soon as I turn my foot switch on, then we'll start creating the arcs and burning the holes. This is super helpful because if you didn't have the switch, basically as soon as you got close to the metal backer, it'll create a large arc and you just end up burning a much larger hole. And same with when you finish and you take away, it creates a big, large arc again. And so if you didn't have the momentary switch, basically your start and stops would be large holes. We're going to go ahead and start. I'm going to put, again, the wand on the backer panel and the piece of paper, and I'm going to go ahead and put my foot on the switch. And we'll do that now. Boom! Woo! Man, that is so exciting. Wow. Really, really cool. Let's show you guys the difference between more voltage, bigger holes, less voltage, smaller holes. Okay, so we're going to do less voltage to start, and we'll do the smaller holes. Okay, those are pretty small holes. Now we crank the voltage all the way up, and we should have much larger holes. Let's actually put up, let's say, a real design. Electricity is fun. Fun, dangerous, but definitely fun. I mean, what a cool project is this. What a cool machine. So, let's say you have this design and you're going to paint it on a wall, right? Let's do the perforations and then we can transfer this design exactly to a wall or glass or whatever substrate. Put the wand on our paper and we'll put our foot on the trigger and get going. Whoa! And obviously I'm kind of just cruising through this, and perhaps if I wanted it perfect, I would take a little more time and make sure it is perfect. But for the demonstration purposes, this is good enough. All right, for like straight lines, obviously you can freehand it or you can use tools to help you trace it. Using a metal ruler is a big no-no because if you take your wand and touch the metal ruler, it's going to arc to the ruler which you're holding. So you're going to get a nice little pleasant little shock. Instead, you can use things like plastic or wood tools to help you get a straight edge. So here's my machine. Man, I'm super stoked on how this thing turned out. I think it looks great. It looks vintage. It looks period correct, and it performs really well. Used electronic Pounce machines you can find on eBay for $800 to $1,000, maybe more, maybe less if you get really lucky. But again, you're gonna have to wait and hope one shows up that's in your price range. Now you could buy one off the shelf, but again, that's $1,600, and for either option, that doesn't include shipping or taxes or whatnot, right? So pretty pricey. So all in all, my machine, my build, I'm sitting at right around $700. In fact, I think it was $706 exactly. I cut my price by half if I were to buy brand new, or still save myself a few $100s versus buying off eBay. And just the fact that I was able to make it myself just is really cool. Perhaps in the future, although it's not really needed, especially for my case, but just to maybe make this product even better is probably adding a 2-stage power entry module. And basically the idea behind that is just to kind of further reduce any sort of electrical noise that may interfere with electronics. But for me, as long as I make sure I don't have any valuable electronics right next to this machine, it really hasn't impacted me enough for me to really need to do that at this point. So for now, it works as is, but maybe that's something you would want to add on your machine. But functionally, this machine is doing exactly what I need, and I'm really happy with the outcome on it. I'd love to know what you guys think about this project. Would you make one yourself? And if you do, send me pictures. Seriously, I think this is really cool, and I'm very fascinated by other home builds. So if you make one, if you're inspired by this video, for sure, reach out to me and show me what you build. I'm super curious. Well, that about wraps it up. Thanks for watching. See you guys in the next video.